All right, so we're moving on to section C in chapter 5. And this is the last section that we're going to do before our next quiz. We went through 5A and 5B fairly quickly because it's really something that you guys should be able to do just looking at it one time. But this section, we're going to take a few days on it. All right, this is probably the hardest part of your next upcoming quiz and test, is writing radicals in simplest radical form. So our objective is to simplify radicals as much as possible. All right, so that's all that we're trying to do here today. So just like you will never leave a fraction 4/8 because we know we can rewrite it as 1/2, we can simplify it. We never leave radicals in unsimplified form. All right. After we take this quiz, we'll start learning how to add and subtract radicals, and you'll see why simplifying them could be so important. Because questions that you think you can't really do, you can't do anything with them, you now can. You now can extend it, and you can now perform other computations with it as well. And if you leave things unsimplified, it just becomes sloppy and messy for you to work with. So you always want to have everything as simplified as much as you possibly can. All right, so this video is pretty much just going to be going over some examples. There's really no definitions. There's no key terms. I'm going to show you what I will suggest for you to do. It's going to be something very similar to what we already did with filling out that sheet, but it's just going to be a little bit different. And then we will just go through a bunch of examples. All right, and then that'll be it for the video. All right, so just like I had you guys do for the other indices that we were doing, rather than making you guys multiply 8 to the 3rd power every single time or whatever it was, I had you fill out that sheet so that way you can just use that as a cheat sheet. You're going to do the exact same thing for this chapter as well. The only difference is it's only going to be x and x squared, right? Because we're only going to be dealing with square roots when we're simplifying for the time being. Next year, it will be extended to the cubed root and 4th root and so on. But for right now, we are just focusing on the square roots. So when you go to do this next year, if this is something that you think is helpful, what I'm showing you now and how I'm going to show you to do it, then you might just need to extend this table a little bit more because you'll be dealing with cubed roots and 4th roots and so on. But for us right now, we're just learning how to do it. So we're simply just going to focus on x squares or the square root. All right, so now let's just go ahead and fill in all these squares real quick. I will give you a piece of paper in class, and the paper will be a little bit more than just 12. You'll have to know up to 15 or 16 around there. But just pretty much up to that point. But what we're going to do is just same thing that we did before. We have x and we have x squared. So we're going to square all these. So 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. All right. The reason why I have you do this is because when we're simplifying radicals, we're looking to see, are there any perfect squares in this number? And all of these here are perfect squares, meaning that we can take the square root of them. And since we're squaring them, we know that any number that we square, if we take the square root of it, the square root and the square will undo each other, and it just brings us back to our value x. All right. So that's why we're looking at these numbers specifically. All right, so let me go through one example with you. All right, this one's probably the easiest one, the square root of 8. So what we're trying to do is we're trying to take out any perfect squares, any number that is embedded in 8 that we can actually take the square root of, and we're trying to remove it. So what we do is we look at all of these values here. Right? We look at all of these values and we see, do any of these divide evenly into 8? Because if they do, I know I can take the square root of it because I know the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Square root of 25 is 5, and so on. So we look, do any of these divide evenly into it? Yes, 4 does. No other number does because they're all greater than 8. So then I ask myself, well, how many times does 4 go into 8? Well, I know 4 times 2 is equal to 8. So instead of writing it as 8, I rewrite it as 4 times 2. All right, so now what I have you do is, remember, we were learning the one rule, that if the square root of a times the square root of b, that is equal to the square root of ab. And I gave you another rule that if we are multiplying two numbers, we can separate them if we need it to as well. This is where that's important. So once you figure out what number divides evenly in, what perfect square divides evenly into our number, so 4 does, we rewrite it as 4 times 2 because that's what equals 8, and then we separate them. So it's the square root of 4 times the square root of 2. And then we look at them individually and say, well, can I take the square root of either of these? Well, yes, I know the square root of 4 is equal to 2. So instead of square root of 4, I can write 2. And then it's times the square root of 2 because I can't take that. And this is our final answer. The square root of 2 times 2 is the exact same value as the square root of 8. So if you plug these into your calculator or into your phone, you'll see it gives you the exact same decimal value. But it's rewritten in its simpler form. Right? So that's why I think it's important for you guys to draw this chart or to use this, because you're looking for these specific numbers. You are looking for any of these perfect squares that go evenly into the number that we have. All right, so let's go ahead and do another example. All right, so here I have the square root of 18. So same thing, I'm going to look at all of my x squareds and say, do any of these numbers divide evenly into 18? Well, 4 doesn't, 9 does, and none of these other numbers do. So I know I'm going to use 9. That means I have a perfect square, a number I can take the square root of, embed it in 18. So I rewrite it. Well, 9 times what gives me 18? 2. And now I can go ahead and separate these. So it's the square root of 9 times the square root of 2. And then I look and say, well, what is the square root of 9? Well, I know it's equal to 3. So square root of 9 is 3. So it's 3 times the square root of 2. Remember, do not write this multiplication symbol. So it's simply 3 times the square root of 2. All right, these are the exact same. Whoops, these are the exact same. They're equal to the same value. So if you plug them into your calculator, they'll give you the same decimal value. But this one here is in its simplest form. Right now, you do not have to do this step if you do not like. And you do not have to do this step where you're drawing it as multiplication. You can go straight from here to here. I do want to see this step here, though. I do want to see what two numbers you're multiplying to get to your original number. So don't just go straight from the answer to from the question to the answer. I do want to see this step here at least. All right, let's do the next problem. All right, I'm actually going to erase this over here because we don't really need this rule anymore. And this one, I'm going to show you 2 ways you can do this. All right, so same thing. We start saying what numbers divide evenly into 72. All right, so we look. Does 4 divide evenly into 72? And if you're not sure, this may take you some time to actually go through and do your divisions. But yes, 4 goes into it 18 times. Does 9 go into it? Yes. 9 goes into it 8 times. Does 16 go into it? No. Does 25? No. Does 36? Yes. All right, 49 doesn't, and none of these other numbers do as well. All right, when you have multiple numbers that go into it, you want to take the largest number. So that means we're going to use 36. All right, so that means that here we can rewrite this as 36 times 2. Right? And then we can go ahead and separate them. It's the square root of 36 times the square root of 2. The square root of 36, based on my chart, I know is equal to 6. So it is simply 6 times the square root of 2. Right? If you're looking at your chart and you're going through your numbers and you notice 2 numbers go into it, if we multiply these 2 together, 4 times 9, that guarantees that this number 36 will also divide into it as well. All right? But the reason why we're taking the largest number is because it's just making us do less work. So let's just go ahead and just do 4, right? So if I rewrote 72 as 4 times 18, and then I separate them, well, 4 times the square root of 18, well, the square root of 4 I know is equal to 2. And if I look, we already did the square root of 18. We just did it in the last question, so I know this can still be simplified. So if you pick a smaller number, it's not the end of the world. It just means you're going to have to simplify or keep going and keep simplifying, because 18 I know can be rewritten as 9 times 2. So I can do 2 times this, and then I can separate them. 2 times the square root of 9 times the square root of 2. Well, the square root of 9 I know is equal to 3, so it's 2 times 3 times the square root of 2, or 2 times 3 is 6 times the square root of 2. So it doesn't matter which way you do it. You are still going to get the same answer, but if you notice, if you're using the smaller numbers, it's going to take you a lot more steps than if you're using the larger number. So that's why we always want to just trying to find the largest number that we possibly can, just to make it a little bit easier for us. But if you use a smaller one, it's not the end of the world. You can still get it. All right, so for this one, we have the square root of 150. So I'm going to go through these. Do any of these numbers divide evenly into it? Now, you don't have to necessarily check every single one. All right, you can jump to one number that you automatically know goes into it. That is a perfect square. And then you can simplify it, and then you can look at your number again and say, well, can I keep going? So I know right away that 25 goes into this. So since I know 25 goes into it, I'm just going to go ahead and write it right away. 25 times 6 is 150. I'm going to separate them. So the square root of 25 times the square root of 6. Square root of 25 is 5. So it's 5 times the square root of 6. Right? I'm not going to circle that just yet. And then, since I only checked one number, not any others, I need to look and say, can I simplify the square root of 6 anymore? So since I can't, now I know it's my final answer. But if I could, then I would just have to keep going. So you don't necessarily have to divide all of these into it, because that could take you a long time. So if you know for sure that one of them does, then you can go ahead and just start with that number. And then you just have to simplify maybe once or twice. But it could be a little bit quicker than going through all these digits and trying to divide every single one. But we're just looking to see, do any of these numbers divide evenly into the number that we're given? All right, so same thing, square root of 288. We have to simplify it. So let's just go through. So I know 4 divides evenly into it, because I can tell 4 goes into 28 and 8. So I know 4 does. I'm just going to look through these quickly. 9, 16, 25, 36, 49, 64, 81, 100. Whoa, I see this last one, 144. Well, if I multiply 144 by 2, that gives me 288. So I would then do 144 times 2. We can separate the 144 from the square root of 2. And now I know square root of 144 is 12, so it's 4 times its square root of 2. All right, so you don't necessarily have to go through all of these. Maybe give a quick glimpse and to see, do any of these jump out at you? You could have done a little bit more, and that's fine. You could also make a factor tree if you'd like, and then you would find the certain number that, like the same digits that you have, you can pull them out if you have 2 of them. I don't want to go through that way with you. If you would like to see the factor tree way, come and see me during lunch or after school. But this is the way I would like to have you guys do this for right now. All right, there's one more example we're going to go through, and then that's it. All right, then the last one is a square root of 700. So anytime I see a number as 100, or like a clean 1,000, 1,000, 2,000, whatever it is, or 700, 300, 400, and something like that, I know right away that 100 can divide evenly into it. And I know that 100 is a perfect square, because the square root of 100 is 10. So this one's actually really easy. We can rewrite it as 100 times 7. And then I can separate them. Square root of 100 times the square root of 7. Well, the square root of 100 is 10, and the square root of 7 we can't simplify, so it's simply 10 times the square root of 7. All right, that is it for this video. I went through 6 questions with you guys. There'll be some questions that we'll go over in class as well if you guys need any help for this. This can be a little bit challenging, but once you do it a few times and you just practice the procedures and you practice the steps and you know what to look for, it's actually not that bad. It's just, you can't be intimidated by it. And you have to remember these steps. Right? You guys seem to, when you learn new rules, you seem to apply them in ways that aren't real. So for instance, when we learn x to the negative 2 was equal to 1 over x squared, or if we had 5 to the negative 2, it's equal to 1 over 5 squared. Right? What you guys started to do in your last test is, if I gave you negative 5, you started writing it as 1 over 5. You started to apply any negative you saw, you just flipped. But it's negative powers, right? So a lot of times you guys just seem to focus on one thing. And anytime you see it, you're just jump into conclusions. So just make sure you're taking your time for this and just learn the procedures and the steps. And it's really not that bad.